for you to drop your questions on our chat box. Okay, perfect. So now, before we start, so I'll first do a small introduction there on our IBC as for IBC as a company, who we are, and all the employees. And then I'll then hand it over to Vessel, who will then give you a small tour guide on our portal. And then we'll hand it over to our IBC AG, who will be handling the whole training today. So welcome, everyone. And yeah, if you do have any questions, please feel free to drop the questions on the chat box. So as IBC, we have our brand offering. So on the module side, we do offer our own IBC modules and also Longi and Jollywood. And on the inverter side, as you can see, we do offer SMA, Fronius, Victron, GoodWe, Attest, and SunGrow. So Attest and SunGrow are still all new products that we put into the portfolio not so long ago. And on the storage side, we do have our own local battery, which is SolarMD. SolarMD, a local manufacturing company based in Cape Town. So we do have a good relationship with them. So if you do have any questions on that, please feel free to also drop your questions on the chat. And we do also offer BYD batteries, which is also a Chinese battery, well known worldwide. They don't just only do batteries, but they also work on EV cars. So as IBC, we do have Daniel, who is the managing director, and we do have Helge, who is the operations manager. And on the marketing side, we have Zane and Carmen, who are also responsible for this training today, organizing it. So thank you, guys. And then on the supply chain and sales administration, we do have Shemaine, Kim, Michaela, and Tanya, who work together hand in hand there. And on the accounting side, we have Hamu, who's responsible for all the accountings for IBC and our premium client. On the sales side, we do have Leo, who's responsible for Joburg, along with Jason. So if you do have any questions, in terms of your orders or anything related to that, please feel free to contact Leo and Jason, who are based in Joburg. And then on the Western Cape side, we do have David with Ridar and Carl, who are responsible for the sales, not just in Western Cape, but mostly the coastal area. So if you do have any questions or you don't know who your sales manager is, please just drop a text on our chat, and then we will then make sure that we get you in contact with your sales manager. On the technical department, the side in Cape Town, you have myself, Honte and Jama, who we are basically responsible for the Western Cape region. And if you do have any technical questions, please feel free to then contact our technical department, and one of us will then be in contact with you. And on the Joburg side, we do have Vessel, who is responsible for the Joburg technical department. So if you do have questions or do need technical assistance that side, Vessel will be your main guy to go to. And just a little bit of a heads up, we do have online portal training every second week of the month. So your allocated sales manager will then give you a tour guide on the IBC online portal. So if you do want to be part of that, if you do want a little bit of training, please feel free to contact your sales manager. And as I said previously on the other slide, if you don't know who your sales manager is, please just drop a text, and then we'll then just make sure that your sales manager gets in contact with you. And also another thing that we recently came up with, thanks to the marketing department, we do now have our webinar recordings available, past and future. So we will be then uploading all our webinar recordings. So if you want to go back and revisit all the trainings, you can feel free to do that. Zane will then just drop a link shortly during our training on where you can find all the webinar recordings. So our special sales deal for this month is we are offering a free delivery for anything exceeding 500,000 Rand, excluding VAT. So make use of this deal. If you have a commercial site or whatever it is and you're ordering and it's above 500,000 Rand, excluding VAT, please contact your sales manager, and they will then just make sure that everything is then allocated to you accordingly. don't miss out on this deal, make use of it, and maximize on your savings. Another sales deal that we do have is you can get up to 100 free corrugated metal sheet adapters if you purchase our mounting structures for corrugated roofings. So this is 100 free. So I mean, if I was myself, I'll probably buy it. But anyway, it's perfect for solar installations. Our adapters enhance stability and ensure easy assembly. So please contact your sales manager if you want to get more information on this. And yeah, we get 100 free corrugated metal sheets for all of you installers out there. And now I'll just hand this over to my colleague, Vessel in Joburg, who's just going to give you a small tour guide on our mounting structure. Vessel, whenever you're ready, you can just take over.
Thank you, Alton. How's it, guys? Vessel here from Joburg. Let me just quickly share my screen here. So basically, the main once you log into the portal, you will be directed here to the home page. And if you go to the overview menu of the mounting systems and you select there, it will display all the different types of mounting structure for the different types of roofs that we've got currently. And in each separate category, everything is in that specific category for what you need for that specific roof type. So if we go into the tile roof section, for instance, it will show you all the various clamps that we've got between the 30 mil up until the 35 mil clamps. Then we've also got our new end clamp range also landing soon, which can go from 30 to 50 mil. So your G3 structure is the more premium range, if I can put it like that. You will also see a new addition to our mounting structure range is the aluminium roof hooks that we introduced. This specific Mammoth SV Plus is for your landscape orientation mounting on the tile roofs, which previously I know that you guys inquired about. And on the second page, you will find the stainless steel versions of these roof hooks. Just want to go back to the corrugated just to relate to what Alton said about the special that we're running on this sheet adapter. Please note, if you do use this sheet adapter, you would need the 120 mil Eco bracket that goes with it. This will be this that basically screws on top of that adapter. So with this, you can make a single layer or two-tier mounting structure on the corrugated roof. You will see some products do interlap with each other, as they can be combined for the different roof types as well. So for instance, you will find under your corrugated roof, you'll find the roof hooks, but under your IBR roof, you will also find the solar fasteners as well, which can screw into your steel purlins where your IBR roof sheeting is mounted to. Then just to head over to our side, we did recently also introduce Canadian solar into our product portfolio. And then if we on your more premium black panels, that's exclusive to our IBC range. So on the Longian, Canadian, and Jollywood, we only do the silver frame modules. Black frames is only on our IBC modules. Yes, that's. If there's anything else that you specifically inquiring about, just drop it in the chat and we'll get back to you. I will then hand over to Simon, our colleague from Germany, which will take over the training from here. Thanks you.
All right, thank you. So I will just start share my screen. Hopefully you can all see it now. And so for today we will do a bit of technical training. first of all, the basics of modules and cells, how they are manufactured, and what are the specific informations you need to know about modules. And after that, we will go over to the mounting structure, what Wesel already showed in the portal or in the IBC shop. And I will try to explain you with pictures how you can easily mount the systems, also now with the corrugated adapter. And then we will go first to the modules now and then the mounting system. And if you have any questions, just feel free to write it in the chat or directly ask it. It's absolutely no problem. So I would start now with the training for the PV modules. First of all, an overview of the concepts, what is possible to do with solar cells, and what we are now at the moment doing with our PV modules is we create monocrystalline modules. What has been also up to date for about 5 or 10 years ago are the polycrystalline modules, but at the moment the monos are the standard or up-to-date modules for the wafer. What kind of manufacturers do we get? Doesn't matter which manufacturer it is, if it's Jinko, Longxi, or even also manufacturers we have here in Germany, but mostly and about more than 85% are coming from China. So China is producing over 330 gigawatts, and there you can see they have a lot of how do I say it, force to keep the production of the PV modules for all around the world. And as you can see here, Longxi is taking more than a quarter of all the manufacturing of PV modules. And this was from 2021, but this is also at the moment up to date. So this hasn't changed a lot. So this is now getting a bit technical, but you don't have to remember every information that is standing here on this slide. Just that you have seen it or already have read it, that we have 4 different types of cell concepts. So we have the BSF type, the HJT type, IBC type, has nothing to do with IBC solar. It's just the IBC type that is called like that. And we have the PERC. PERC has been the most up-to-date concept until let's say about 1 or 2 years ago. But what came after the PERC is the TOPCon technology. TOPCon, what is the reason why we use that? It has an increased efficiency. So because of that, it's a new, let's say it's written here in the mainstream, just because it has an upgrade instead of using the PERC production. First, you also have a cost reduction if you're using TOPCon, but not to get any technical, just that you have already heard it. For example, here at the bottom in the picture, you can see the cross-section of PV module. So this cross-section is less than 1 millimeter. So this is really, really thin, a solar cell. And it has been the PERC type. But as I said, the TOPCon technology is now up to date for most of the modules that are now in the PV market. What kind of layers does a PV module have? So here it's pretty nice to see. First, of course, you have the frame. As Wesel already said, it can be black or silver. IBC modules have, for example, in South Africa, mostly black, but we also have silver variations. For example, here in Europe, is also a bit cheaper, but as I said, can be black or silver. Then you have the glass. It's very important that the glass is as thin as possible, because you want to have all the sun energy coming through the glass and not going back. So this is really, really important. After that, an encapsulant, And the main thing here are the solar cells. And this is what I just showed you, what has a cross section less than 1 millimeter. So it's really, really thin. And regarding these solar cells, what you have on top of that are these bus bars. So you can always see on solar cells this small silver stripes. These are called the bus bars. And the solar cells are typically a full quarter, but what is now already up to date, also in the IBC modules, is the half cut technology. Half cut means that you just cut these cells in half and just connect it with the bus bars. And this has a reason because the efficiency of the modules is increased and you get a few % more from the efficiency from the PV module. Behind the solar cells, typically you have the backsheet that can be white or black. So for the black modules, you typically have the black backsheet, and the other ones have a white backsheet. But what is also possible is that you have, or you don't have a backsheet, but you can also have a glass on the backside of the module. Then you would have a bifacial module. Means that the sun that is shining onto the module goes through all the layers, and if maybe you have a white underground behind the module, then the sun shines back onto the module and you can get a bit more power into the module because you don't only have the sun shining onto the top of the module, but also from the back. So this is the simple way to show how PV modules are manufacturers and what are the single layers of a PV module. Just to also announce what kind of wafers do we have is at the moment the M10 wafer. M10 means this is the size of a single solar cell. A few years ago, it has been G1 or M6, but just that you have heard it, at the moment, the normal wafer size for solar cells are M10. And there you can also see the measurements from these wafers. And this is really common for all manufacturers around the world, that this M10 is up to date for, let's say 95% of the PV modules you get at the moment. So the modules with the half cut design, as I already said, they have an increased efficiency, and because also the modules, if they bend, the whole solar cells could break, and this is a big advantage you have with the half cut technology. The modules bend and you don't lose the efficiency because of the bending of the cells. So this is the, let's say the most important advantage you have at this point. The module is designed from two parallel halves. So you have the upper half and the lower half. And as you can see here, they are connected first between the single strings, and you have the cell connector. So the cell connectors go from one half cut cell to the other one. And in the middle here, you have the string connectors that all the parts from the module are connected to one, and you get one closed circuit of voltage and current from the module. To make it a bit more clear, this is now a module that is not in half cut. These are the full solar cells, and here on the top you have diodes. What do these diodes do? If you have a shadowing on the module, like let's say it here on the bottom right, there's a shadow, and if there's a shadow, then the diodes switch. So the current can flow through the diodes, and for example, you have 3 diodes, means the first 2 rows have 1 diode, the third and fourth row have 1 diode, and the fifth and the sixth row have 1 diode. And if you have a shadowing, for example, here in the 6th row, what happens? The diode gets activated and the current just flows through the first 4 of the rows, and the third one just gets skipped because the current flows over the diode, and this protects the PV modules from any further damages. And just to come over to the half-cut design, for example, at the half-cut design, you have 6 of these diodes, means these diodes are located in the middle of the module, and on the left you have an upper and a lower part. In the middle you have 2 parts, and on the right side you have 2 parts, so you have 6 diodes. And for example, if here now the shadowing would be on the top, on the bottom right, then there would only be half of the size we have now and would be skipped, and you get even more efficiency from the module. So this is the big advantage you get from the half-cut design. Yeah, modules have to be tested to get clear what is the quality of the modules. As you can see here, if you have a hailstorm with such big hails, then I think your modules won't survive that storm. So this is really just not that often that this happens, but has been already at any day on this earth. But for normal hailstorms, for example, you can see it here, they are already tested with an hailcorn form. I think they are 1 centimeter diameter, and they get shot on the modules, and the module even breaks or it doesn't break. This pretends on what kind of glass you have and how big or how thick the glass is. And what you can see here is a testing table where our modules get different loads. For example, if you are in regions where you have a lot of snow loads, then you can test it here and put the pressure, like the loads, onto the module, and then you can see, okay, this kind of value you can put onto the module without breaking of the solar cells. And these are also the, for example, design loads, which are at the moment for our PV modules from, I think, 1,600 pascals, means 1.6 kilonewtons per square meter. So there you can see how these modules are tested and how these values are not just calculated on a paper. So this is really tested practical, that we can say, okay, the PV modules have this quality and can get through these windstorms, snowstorms, or everything like that. Yeah, what kind of variants can you get for modules, not just from IBC, but from also, for example, Longxi or Canadian Solar? So we have the standard white one with the white backsheet. We have the black ones with the black backsheet, and we have the bifacials. It's now a bit difficult to see, but bifacials, as I said, have the glass in the front and also in the back, so that you can increase the efficiency and also get the energy from the back of the module when the sun is shining through it. Yeah, here you can see the brands, but this is just for our European market, like for example, what you get in the German IBC shop. There also we have something like Santec, or Meyer Burger is the biggest one in Germany, as far as I know. And to see, like in South Africa, as we already saw in our IBC shop a few minutes ago, you have IBC, the Canadian Solar, Longxi, and the Jollywood. IBC Solar are the modules around 400 watts to 420. Canadian Longxi and Jollywood already have modules up to 550 watts, I think. This is just the reason because the modules have a higher surface, means they are over 2 square meters, and because we have a regulation here in Germany and with the IBC solar modules, that in Germany you have the 2 square meters is not allowed to be over that, and so IBC solar only has up to 2 square meters, and this means we can't use that much solar cells, and then we can only get 400, 420 watts. in difference to the, for example, Canadian solar, they have over 2 square meters, and then they have much more solar cells, and so they get up to 550 watts. And what is even the name? So this is pretty new for the IBC modules, and maybe it's not already up to date also in South Africa. So this is just coming in the future. This kind of module names at the moment, they are a bit different, but just that you know what is meant when you read this kind of module names. IBC, should be clear, is the distributor. We have modules, white or black or bifacial, as I already said, depends on what kind of backsheet or glass you have. 440 is the rated power. So 445, I think, is at the moment the biggest one we have from IBC. And ES is just the manufacturing side. So we have different manufacturers. So for example, we have an MS, ES, or also an OS module. And after the stripe, you have the T, means the cell technology. As I already said, the TopCon technology is up to date. So it's the newest one and has the most efficiency. So we, of course, use the TopCon technology. And an A at the end is just an internal marker for us, for cell numbers. So yeah, this is not relevant for you. So this is just an internal information. Just that you know, if you read a name for a module like that, that you know what is meant with every word you can read there. And at the end, as I already said, we test our modules for such high qualities. As you can see here on the right side in the picture, this is the test table, what we already saw, and where we test different loads for pressure and also suction. As you can see here, the module has a suction to the top. For example, if you have higher wind loads under the module. What we also have is climate chambers, means the modules get in there, and there you have for 1 hour, for example, you have minus 60 degrees, and in the next hour you have up to plus 70 or plus 80 degrees Celsius. So here the modules are also checked for climate differences. And to prevent that, you also get the rated power that you buy for the modules. For example, a 440 watts module. This is tested here in a flasher, means there is a flashlight that is used for every module test all over the world. This is always the same flashlight. And then you can see, okay, the PV module gets a rated power of only 430 watts, or it gets the rated power of 440 watts. And then you can see, okay, the module is all right. It doesn't have damage, and you get the efficiency you also bought with your PV module. So this was the first part about PV modules and cells. Is there any question left at the moment? So if you have any questions, just feel free, write it in the chat or talk to us. You can also unmute yourself. And if there would be no question at the moment, then I would switch over to the other presentation that I will show you our different mounting systems and try to explain how to easily mount these systems. So I don't get any question. I just look into the chat. Marco already wrote at the moment the question back.
Everything's fine, Simon. Just go on with your presentation.
All right. Thank you, Marco. You have the chat in your own. So thank you for that. All right. Then let's start with our mounting system. Also, just 15, 16 slides for this presentation. Try to make it as clear and easy as possible. Again, if there are any questions, just write them in the chat, and me or Marco or also Wessel will have a look at it and try to answer. So what are we going to talk about? We have different roof types, for example, pitch roofs with tiles or also metal sheets. And we have the flat roof system, as we already saw in the IBC shop. Let's start with the tails and tiles pitched roofs. Just for you all to know that we have different profiles. For example, we have the TF50 and the TF60. What's the difference? It's pretty easy. You have at the TF50, you have a 50 millimeter height, and for the TF60, you have a 60 millimeter height. Means also that the TF60 can take a bit more loads, for example, snow loads, than the TF50 because it's, of course, a bit thicker than the TF50. Just for an information that you know what is meant with these profiles. Let's start with the tail pitched roofs. Here you can see a typical solution we have for roofs where you can't use normal roof hook or metal sheet clamps. So these solutions are done with the hanger bolts. These hanger bolts are typically connected onto the rafters under the tails. And onto these hanger bolts, you connect this universal connection piece. There you can also select which height you want to have. So we have this thread here. It's typically an M10 diameter or an M12 diameter. And onto this connector, you can just connect your profiles. And onto this profiles, then you just mount your PV modules. So again, here, you can take the TF50 profiles or the TF60, doesn't matter. Just what you want to use. If you have higher loads, for example, maybe South Africa is not the fitting direction for that, but for example, in Sweden or Finland, where we have also a lot of projects where you have pretty high snow loads, then you can use the TF60 and you can get a few more values for the loads. How is this mounted onto the roof? We just saw a small picture, but here I think it's a bit more clear. You have here a tail roof, and as you can see here on the bottom, you have the hanger bolt, which is connected through the tails to the rafter. And then you have the connection piece, and just simply on that connection piece, you can mount your profile, TF50 or TF60. And on top of that, you just put your modules and fix that with the module clamps. The same type of connection you can do with roof hooks. So for example, if you have typical tiles, not tail, sondern tiles or tiles, then you connect these roof hooks to the rafters as it is seen here and onto the rafter and the roof hook. Then you connect your profile, TF60 or TF60 again. So this is not a big difference. It just depends on if you can use a roof hook under the tiles or do you have to screw the hanger bolts through the roof into the rafter. So these two options, simple as that. Let's go on to the trapezoidal metal sheets. This is, in my opinion, the simplest, the easiest system you can mount. It's the fastest one, and it's also, if you use the eco system, the cheapest one. But we will come to that in a few slides, also to the corrugated adapter. So as you can see here, we have the metal sheet clamps, which are connected or fixed to the metal sheet. And into this metal sheet clamp, you just put your TF27 profile. Also here, 27 profile because it's 27 millimeters high. And in the next pictures, it's a bit more clear how this should be mounted. So you have the metal sheet clamps. They have a type of glue at the bottom. So you can just stick it onto the metal sheet. You don't have to screw it in the beginning. You can just stick it to the roof and it stays there. When you have placed all your metal sheet clamps, like it is shown here on the left picture at the bottom, then you can put in the profile, and also depends on how straight the roof surface is. If you have a bit differences from 1, 2, or 3 centimeters in the height, then you can select different heights for the profile into these metal sheet clamps. And if you have found the right height for your profile, then you can just close the clamp. And if you have closed the clamp, for example, you can see it here, then you can just screw the metal sheet clamps into the metal sheet roof and everything is fixed. I just skipped 2 slides. I will go back to it that you can see how you can mount these metal sheet clamps. We typically use an alternating mounting on the beadings. This has a special reason. So here you have the metal sheet clamps, then one beading is free. Then again, you have one on the beading, one is free again, and so on. This has the reason that the force that comes from the PV system goes on the different beadings and don't always has the same. So for example, if you would use here the metal sheet clamps, the next beading would be completely free. Then we again put here 4 of the metal sheet clamps and the next one is again completely free. Then you would have the double of the load you have than you would have if you have an alternating mounting. So I hope you get it right. And this is the reason why we typically mount these metal sheet clamps alternating, that the force from the PV system goes on different beadings and they are not overloaded. And as I said, if you have connected all your metal sheet clamps to the metal sheet, then you just put in your profiles, and onto these profiles you can clamp the PV modules. This slide we already have. If you have put in your profile, just screw 2 screws into the metal sheet clamps. And what is also important, we have a kind of locking clamps. Why do we have it? So as you can see, the profile is not screwed into the roof or screwed into the metal sheet clamps. It's just lying in there and it's clamped in these metal sheet clamps. But for example, also in South Africa, it's a bit different than we have it here in Germany. If you have such high temperatures for 30, 40 or also higher, and then this aluminium, I would say, starts working. So it expands a few millimeters or centimeters. But if it expands, let's say 5 millimeters every day on a hot day, then it can start traveling into one direction. And to prevent that, we have these locking clamps you put into the profile on the left and on the right side. For every profile, you just use it once, or if you want to go on the safe side, you can use it twice per profile. You just screw it in, and then your profile is prevent from, let's say, walking around to the left or to the right side because of high temperatures. Then we come to the ecosystems. Here we have the first 2, the 340 millimeters and 420 millimeters. Why is it the eco solution? Because you can save a lot of profiles. So you only have 2 metal sheet clamps and 1 type of profile, even the 340 or 420 millimeters. You just connect it to the roof, and also like the mounting with normal profiles, you put them on the roof, and on top of that you put the modules. As you can see here, has the big advantage that you have less material, and if you have less material, also means that you can have it for less costs. So this is much cheaper than the normal metal sheet system. And what is even easier and cheaper is the Eco 120 system. This can be used in 2 different ways. So for example, you have the only the Eco 120 mounting clamps. You just put them onto the roof, screw it to the roof, and you directly put the modules on it. So this is really the easiest way to mount on metal sheets, because you save a lot of material, and this is the main reason why it's also the cheapest reason. But what you can also do with the eco sheets is for corrugated roofs. So this is the adapter that also Wes showed us in the beginning. And for example, if you have a tails roof, you can just connect the system with this corrugated metal sheet adapter. So this adapter goes to the roof, and on top of that, you connect this eco piece with 120 millimeters, and then you just place your modules on it. So as a difference to the mounting with hanger bolts on tails roof, first you save a really lot of time, and it's much easier to mount it. So for these hanger bolts, you first have to screw a hole through the tails. Then you have to screw the hanger bolts into the rafters or into your metal subconstruction, and then connect your universal pieces or the universal connectors. But then they also have to have the same height on every hanger bolt, and this takes really a lot of time. And if you want it much faster, then you can use this adapter, just connect it to the roof, put the ecosystem onto it, screw it into the roof, and then you place the modules onto this eco piece. And as I said, is for tails roof the easiest and cheapest way that you can mount a PV system on it. So just keep that in mind. And at the end, we have different systems for our flat roofs. Maybe the most of you have already seen different flat roof systems that you have an inclination for the PV modules. You can have it into one direction, is called our south system in 8, 10, or 15 degrees, or you can have the east-west system in also 8, 10, or 15 degrees. As you can already see, the south system, the modules all have the same orientation, or at the east-west system, you have two different orientation, and you can get the energy over the whole day and don't have this energy peak at maybe 12 o'clock in the noon, like here on the south system. What do you have to know if you use these kind of systems? It's also written in the mounting manuals that at least you have to use 2x3 or 3x2 modules. So this is the small picture here on the left side. Here we have 2x3 modules. This is the smallest group of modules you can have, because you have to put a ballasting onto the Aerofix system. And if you only have 6 modules, then the whole system has its own weight. That is really low. So you have to put much ballast on it. And if you have in difference here the biggest possible module array of 20 × 20 meters, then the whole module array has an own weight that is so high that you don't have to ballast anything at the most time. So maybe on the edges or here just in the corner areas, but in the middle you don't have to ballast anything, because the whole module array is already so heavy that even windstorms can't put the system away. So also keep that in mind. The smaller your module array is, the more you have to put ballast on it. This is a pretty nice picture. We also have here in Germany, this is in our competence center, where we have a type of foil roof. So this is a flat roof with a foil on it. And on the right side, you can see we have a ballasting module onto our base rails for the Aerofix system, because a few customers already asked us why we use such a high amount of material also for the base rails, because they are so thick. And there you can see what is the main reason. If you put the force over the whole area of the base rail, then you don't have this high value points where all the pressure from the PV system goes into the roof, like you can see it here. These are just simple points, and all the pressure from the weight goes into 1 or 4 points per module. And this is the main reason why we have this kind of thick base rails. Here you can also see it, especially on foil roof or on pretty soft roofs. You can see it extremely good that here these base rails have the force over the whole area of the base rail. And if you only have type of points where the PV system is onto the roof, then you can damage it. And in the worst case, you can get water into your roof. And this is, I think, the last thing you want to happen to your roof system. You can also connect these base rails, should be pretty clear. But also here we have the normal base rails and the eco rails. So here on the bottom, you can see this is the whole base rail, and the ecosystem ends here next to the screw. So the ecosystem is just, I hope you can see my mouse all the time, that the ecosystem ends here next to the screw. And this means you have, again, much less material. And so the ecosystem, as the name already says, is also much cheaper. So this is the only difference. Normal base rails have the full size. Eco rails have less material and have a smaller size. How are the modules mounted onto these base rails? So we have bottom and top supports. And for the bottom support, you can have the single one for example, the end of the module array, or for the south system, or for the east-west system, you have always 2 modules next to each other. And then we have the double support. So this is just one piece you have to connect. It's also easier to mount than if you have to mount 2 of these supports. Of course, then you have the top support for the module. There you have 2 different types. Here you can see typical top support without a wind plate mounting. If you want to mount a wind plate on it, like in the south system, you can see it here in this picture. This is a top support where you have a bit of material where you can mount the wind plate between the base rail and the top support. And for the last slide, of course, as I said, our aerofix system is an aerodynamic system, means it is not connected onto the roof. But if you have high wind loads, or you have pretty high buildings, so the roofs are over 30 or 40 meters high, then in the most cases you have to ballast it. And there you can also select between 3 different options. First of all, on the right side, you can see the stones you use for the ballasting are just lying on the base rails. This is the simplest one if you don't have that much ballasting. But if you have to put a few stones more on it, then you have the 2 options between the normal ballast rails for this, let's say, thick stones. And if you have the flat stones, then we have these L profiles where you can put the flat stones in it. Depending on what size they have, then you just mount your first L profile, put the stone in it, and if you know the size, then you can mount the other L profile and you are fine with it. So these are the 3 options you have between the ballasting, how much ballasting you need, and what system is the best for your roof is the easiest way to create a building in the PV Manager. So PV Manager is our typical calculating program where we also create most of the time the buildings, and then we look what kind of materials you need, because you get a full parts list at the end. And if everything is fine, what you have created, then you also get a statical report. So the statics are approved for that building. So this is just from our side. We always use the PV Manager because then you don't have to calculate it yourself manually, and the PV Manager makes everything for you. It's the fastest way. And yeah, I think, yes, this was the last slide from my side about the mounting system. I hope I have cleared every questions you have. If not, just feel free, write it in the chat, talk to us as you want it. And if not, I already say thank you for the attention, and I hope you could get a few more informations about the two presentations about modules and mounting systems. And that's all from my side. Thank you. Then I would say I give back to Sene or to Wessel, one of you guys.
Thank you so much, Simon. It was a very insightful session. Is there any more questions to just post them in the chat? Let's give it a few seconds to see if something comes
Yes.
through. Otherwise, you're welcome to still post your questions and I'll forward it to Simon to answer at a later stage. But yeah, thank you so much. And yeah, I really appreciate you guys taking your time to help our South Africans out here with the mounting. Thank you.
Yeah, no problem. My pleasure. Yeah. Thank you too.
Then I think that's it. Thank you. Enjoy your day. Thank you, everyone.